Next we will discuss about I.I.R. or a closed loop system which is widely used for digital signal processing applications. All applications, the real-time applications is based on the I.I.R. system. Adaptive filters. So I am a I.I.R. system. I.I.R. means infinite impulse response duration filter. So there are two types of systems in digital signal processing. One is FIR and another one is I.I.R. We just discussed about FIR. Now we are going to discuss about I.I.R. It is nothing but a closed loop system. So for example, it's myself. I am a closed loop system. I am not an open loop system because I have feedback. I won't be similar to today or tomorrow or day after tomorrow or after a year, etc. Every day I will be changing. So based on the inputs, based on the feedback, I may change. So that is the system, closed loop systems idea. If there is a feedback, if there is a change in the system, then it is called a closed loop system. Now we will check how it is defined. So this system is defined as y of n is equal to summation k is equal to 0 to infinity ak x of n minus k minus summation k is equal to 1 to infinity bk y of n minus k. This is called the closed loop system definition in a digital signal processing. So that is also called as I.I.R. Here the present output depends on the past and present input and past output. That is why here it is represented by negative. So the present output depends on the past and present input and past output. If you expand this, you can check it out. A0 x of n plus a1 x of n minus 1 etc. minus b1 y of n minus 1 minus b2 y of n minus 2 and so on. So you can notice here it is k is equal to 0 to infinity and here it is 1 to infinity, because if you substitute k is equal to 0, this will become present output. So the present output depends on this system. So there should not be any present output. That is why it starts with k is equal to 1. So the present output depends on the past outputs. So here the present output depends on the past and present input and past output. That is called a closed loop system. That means it also not only depends on the input, also depends on the output, also depends on the feedback from the output. That is why it is called a closed loop system. Now we will check it out how the architecture is drawn. Similarly, I take an input x of n and output y of n. So y of n is equal to x of n multiplied by a constant a0 plus, and this x of n is divided by one time multiplied by a1, and again it is divided by one time multiplied by a2 and so on. Here it is y of n is equal to y of n minus 1. It is divided by one time multiplied by minus b1, and again it is divided by one time multiplied by minus b2 and so on. So here you can notice this output, present output depends on the present input, past input, past output. Clearly the figure, the architecture shows that present input depends on not only the present input, also the past inputs, and not the present output, past outputs. That is called a closed loop system. Thank you.